When a metal surface is illuminated by light of wavelengths 400 nanometers and 250 nanometers, the maximum velocities of the ejected photoelectrons are V and 2V respectively. The work function of the metal is to be determined in terms of Planck's constant and velocity of light in air. What is the kinetic energy of a photon? It is given by hc, where h is Planck's constant and c is the velocity of light, divided by lambda, where lambda is the wavelength of the photon. Part of this energy is used up in liberating the electron, and that is the work function of the metal. So the remaining energy would be equal to the kinetic energy of the photoelectron. Therefore, we have the two equations: hc by 400 nanometers minus the work function is equal to 1 by 2 the mass of the electron into v squared, and hc by 250 into 10 to the power minus 9 minus 5 is equal to 1 by 2 times the mass of the electron into 2v whole square. Now it is clear that we can quadruple the first equation to get the right hand side to be the same as the second equation. And since we are doing the same operation on both the LHS and the RHS of the equation, it is still valid. So we can say that 4 times hc by 400 10 to the power minus 9 minus 5 is equal to hc by 250 into 10 to the power minus 9 minus 5. Taking the hc terms on one side and the phi terms on the other side, we have 3 phi is equal to hc by 10 to the power minus 9 into 4 by 400 minus 1 by 250, which is the same as hc by 10 to the power minus 9. 4 by 400 is 10 by 1000, and 1 by 250 is 4 by 1000. So we have 3 phi is equal to hc into 10 to the power 9 into 6 into 10 to the power minus 3, or phi is equal to 2hc into 10 to the power 6, which is option A.